going to turn to transferring cultures aseptically. Somewhere on here there's going to be demonstrations. So I'm going to steal somebody's burner. Actually, I'm going to steal this burner over here because nobody is using this burner, and it's my burner. Because we didn't have enough burners, this one was put out, but this normally is my burner. Unfortunately, it's also a different burner from the one that you used. But the points are more or less the same. Gas, of course you don't want to put it in the air. Starting them, you need to apply some degree of pressure upward to make that work. A lot of people actually struggle with these things, and it takes a bit of strength. You need to actually push down. If you just go like that, it really doesn't do anything. So it requires a bit of effort. The burner. So the burner, you want to adjust in such a way that it's low and not yellow. Trying to make it tall and yellow. That's successful. I don't know if you can see that as tall and yellow. But at any rate, if it's barely coming out, you need more gas. You need less gas. And if it's way too high, that's actually pretty good. That's a nice flame. Woo. If it's really high, it's not going to work out for you. You want it relatively low, and there's this place in these where you can heat up your transfer tools relatively fast, faster than other places. There's a hot part to the flame, and it's helpful to actually go searching for the hot part of the flame. In this drawer, we've got some loops. These are transfer loops, making this thing a little bit straight. It's more important with the transfer needles to have it straight. But you put these into the flame, and there'll be a spot in there. Maybe it's right there. That's hottest. If you're too high, it'll take forever. You can actually see that it's kind of become less orange, mostly because the flame is narrower at the top. If you go way down, you can't see this, but it's become not orange at all. So there's a spot in here where basically you can heat these things up fastest, and that's where you want it to be so you can heat up fastest. You want to heat up the tip of the loop, and then you want to go through to the end here, and then I like to do a little bit of the handle. You don't want to do the handle too much because it'll make the handle hot, and then you'll burn yourself, and then I go back to the tip. So what we now have is a sterile loop. It's also a very hot loop. It's so hot that it will kill your organism, so you have to let it sit for a little bit at least so that it will cool off. Now, you don't want to do this. Anytime you catch yourself doing anything that involves taking anything and doing this in this class, you want to say to yourself, I shouldn't be doing that. And that's because there is the potential for, first of all, accidents. I mean, you could hit somebody with it, or it could go flying out of your hand. But also, when you've got organisms on things, you're potentially taking organisms and spraying them all around. And when you are putting stuff into something and you feel compelled to go like that, you're potentially introducing organisms into whatever it is you're transferring to. As I like to say, think of what you're doing in terms of manipulations as though you were working with a body. If this was during surgery, you shouldn't be doing things that are more likely to contaminate that body, the surgical wound. And so you should be thinking all the time about how am I doing, what am I doing, how am I doing it? Am I doing it in such a way that potentially is going to be dangerous to some future patient of mine who I'm trying to treat but not contaminate? Or for that matter, the patient might have microorganisms associated with them that you do not want to get all over everything inside. So that's not how you cool it off. What you do This is a broth tube. Notice how I'm holding this tube. First of all, I'm not holding it upside down because of course it'll spill out. But I'm also not holding it by the cap. It is really tempting to hold these things by the cap, but not all caps are made equal. Some of them are rather old, and when you start holding them by the cap, you potentially are going to have the tube slip out of the cap and land and break, and then it's embarrassing and dangerous. So this is how you can cool off your loop. First of all, because I'm a microbiologist, I feel that I absolutely, even though I know I'm not going to do anything with this afterwards, I feel absolutely compelled to make sure that my loop is sterilized before I put it into this tube. Second, now you're not supposed to be holding it by the cap, but notice that I'm holding the cap with my pinky. Once upon a time I had this, I was playing on the soccer team for OSU Mansfield, and I was in the goal, and somebody had broken away, and it was just me and this offensive player and the ball coming down the field as fast as they could with this ball, and it was like he's gonna get a goal unless I do something really crazy. So what I did is I tried to close off the angle by going towards them, and then at the last moment when the person was about to shoot, whatever one does in soccer, I leaped into the air with my hands in the air and my legs spread wide, and I screamed at the top of my lungs, and the person hit the ball and they hit it wide of the net. And that was one of my great triumphs in soccer. I only had two great triumphs in soccer. That was one of them. But I landed and I dislocated my pinky, and it was only at that point in time that I realized just how important a pinky is in microbiology, because I couldn't really do this. But what this is for, it allows you to do that. That way you're not putting the cap down. You can be fancier than this, and you can take off two caps at once and have two tubes in your hands at once. And this allows you to go into one tube and then transfer it to the next tube. But this is how I do it. You need to, before you take anything out, you need to flame the lip of the tube. And what this does is it kills any organisms that are on the outside. Now I'm already feeling that I really should be flaming this again, but I'm not going to. If this were still too hot, one way of cooling it down is to touch it at the top of the glass there, because the glass is relatively cool and conducts heat better than the air does. And so it's just a way of removing heat from the loop so you don't kill your organisms. If when you take your loop and you actually touch it to the broth or you touch it to the agar and you hear, you know it was too hot. Then when you have done whatever manipulations you're doing, you flame the lip of the tube again and you put the cap back on. You don't want to make it too hot because that will melt the cap, and then some future individual will pick it up by the cap and it will drop and break. just worth keeping in mind. So flaming the rim of the tube, transfer from a slant, transfer from broth. I knew when I was over here that I should grab a slant. And I'll grab a deep as well. Okay, so we've got three types of media here. You'll note that I am holding these with my fingers on the glass. So I'm not just holding it with the cap. There's broth on your left. There is a tube, a deep tube for stabbing in the middle. And there is a slant tube on your right. Both the slant and the deep are agar-based media. They're solid media, or semi-solid media, as they said. And then the broth is just liquid. So it says transfer from a slant. So the first thing you do is you take your handy-dandy loop, or alternatively, you take a transfer needle, which I'll show you in a sec. So I'm taking that. This is my slant. Taking it off with my pinky. Flaming. And then you go in, you cool this thing off. And then to make a transfer, assuming that you cool it off, very important that you cooled it off, because that will be what goes wrong. If it's way too hot, it'll just kill the organism. If you don't have it too hot, all you have to do is touch the culture on the slant. You don't have to be fancy. Now I understand the tendency to want to take up as much culture as is humanly possible when you make your transfers. You honestly, I missed. You honestly don't want to do that. It's not that big a deal when you are transferring simply the cultures from one place to another, but when we get to making smears in order to make our slides that we view through the microscope, it is all too easy to have way too much organism on the slide. And so you really need to practice and get in the habit of taking a relatively small amount of organism when you're doing your transfer. So that's transfer from a slant. Transfer from a broth. So before you put your loop down, you make sure you reflame it. This is all part of, you've already made sure that you haven't contaminated your culture. Now you want to make sure that you don't contaminate your surroundings with the organism you're working with. So this is our broth tube again. Again, I'm holding it with the glass. I'm doing it subtly. I'm not doing this or this. But I am holding the glass. So one of the things that goes wrong when you have a culture in a broth tube that you're transferring from is the culture can settle out. And in fact, you may even have cultures over here that have settled out. So we've got some relatively big organisms that like to settle. Or maybe not. Yeah, I guess the micrococcus. Yeah, it might be. Okay, so let's see whether or not it's settled out. So this is a broth culture. It contains an organism called Micrococcus luteus. And if it settles out, then you'll actually have lots of organism on the bottom, but you won't have organism in the broth itself. And then when you go along, as I'll show you, and go to transfer from this tube, you won't actually be picking up organism. So how do you deal with that? Well, you get in the habit of doing this. Again, I'm holding it by the glass. If you go like this, you can do a little bit of vortexing. And if there's organisms sitting on the bottom, it will basically, you'll be able to see it coming up. And that will make sure that, in fact, there are organisms in what you are transferring from. Now, we also have these devices called vortexers. Now, these can be a little dangerous. In order for these things to work properly, you have to hold onto the tube, not too tight. But if you don't hold onto it tight enough, it picks it up and it throws it across the room. You also have to be careful because when you actually do the spinning, if you get too much vortex, if it's set for too high, which it might be, then you end up with it spraying out and it'll make a big mess. So I'm going to assume it's too high, so I'm going to be very careful. Note again, holding it with the glass, also got my finger on top. I don't know why I have my finger on top. Probably because it's easier. Probably because it makes it easier to hold it so that it's less likely to fly out of your hand, I'm thinking, is why I do it. So that didn't work at all. I'm guessing that's not, oh yeah. The obvious thing. That happened to me the other day. What was I doing? I was doing something where, there we go. Where the one thing I didn't check was whether or not it was unplugged, and of course that turned out to be the problem. Okay, let's try this again, thank you. So this one, it's not the greatest one in the world, but you can, actually this is, yeah. So you don't want to just, you got to stop it before it gets to the point where it basically overflows. Because then it makes a mess. You don't want to make a mess. So anyway, that's resuspending the culture. I probably say it a million times in this text. Make sure the culture is resuspended. You got to make sure the culture is resuspended if you're going to pick up culture. Now, let's see, transfer for broth. I'll transfer for one that doesn't have organism. So once again, I'm flaming my loop. It's good to flame as high as you can get away with because you're going to be inserting these things into tubes. And you don't want to be inserting much into the tube that actually is potentially contaminated. So I'm going to go in here. I'm going to let this cool off a bit. moving my fingers so that you can see. And then I'm going to go down, and what I like to do is just kind of scratch it along the air-glass interface, air-glass broth interface. Because that way you're getting stuff potentially on there almost no matter what you do, and you're not plunging it too deeply in there. What you don't want to do is, ooh, that was unfortunate. It's a good thing I didn't do it in the regular culture. Now that's what you don't want to do. It's very subtle. I'm going to, how should I do this? It is sterile, but I feel compelled to do that. But once I do that, then I won't want to touch it, which means I'll have to go over here and get another one. And I'll use this as an opportunity. See, I did this intentionally, thank you very much, to grab a inoculating needle. So inoculating needles, you want to make sure are straight. It's probably best to actually flame them and then let them cool off before you straighten them out. But having them straight is important because ultimately they're going to be used for stabbing into agar. And the straighter it is, the cleaner the stab is going to be. So I just want to demonstrate how I cannot not flame these things. So what I often see people doing when they're trying to transfer is they go in and they go, you really don't want to do that. I mean, think about the potential for having things fall into your tube when you do that. But what you do is you just go in and again at the air-liquid glass interface, just kind of scratch it. You know, if you need to have some kind of mechanical action to release the organisms, that will provide that. You only need one organism to be transferred for you to have a successful transfer. I actually did something wrong when I was pulling the thing out there because I had it up against the glass and it was a little bit with pressure on it, and when I pulled it out, it essentially released like a spring, and that undoubtedly caused organism to go flying through the air. So it's important to keep that in mind. Of course, I did this with a sterile broth tube, so it's not an issue, but it can be. So let's see, so transfer into a tube, so you would go into that tube and just scratch it at the air interface, air glass liquid interface. If you're going into a slant, there's actually two ways of doing this, actually three ways of doing this that I know of. So using a needle, you would go in here, now, oops, clearly my eyes are going, I missed. Actually, an easy way to avoid missing is to move the tube and not the inoculating tube. But what you do with the needle is you basically start at the bottom with something that's already been inoculated, and you go on like that. You don't flame. If you're inoculating, if you're taking it from one place to another, you don't flame in between. You're trying to actually transfer something that's alive. So you end up with a nice straight line. If you are doing a transfer, well, I can't stop doing this. Even though I know this is sterile. I am going to use this as an opportunity. This is an opportunity to fix this poor thing. So, when you are maybe you do a very good job fixing it. When you're transferring from a loop, it's quite typical that you will transfer such that you do a kind of squiggle going up. Old habits die hard. So, if that were the surface of the slant, you'd be starting at the bottom and going like that. When you're transferring with the loop, when you're transferring with the needle, you would start at the bottom and go like that. Okay? And what else do we have here? Transferring to the tube we've done, transferring the slant using the loop we just showed you, transferring the slant using the needle we just showed you, and then we have transferring from a plate. There's our plates. So these plates were quadrant straight. This is going to be something that we learn. It's a way of isolating organisms. The goal is to have isolated colonies, and there are nice isolated colonies on this plate. When you're working with a plate, Now, to transfer from a plate, I'm starting with a sterile loop. You either let the loop cool off, or if you trust your technique, you can actually touch it to the agar surface to make sure it's cool. And then you find a isolated colony. You touch it to the colony. Again, you really don't have to touch much, although I really understand the desire to actually have enough on there that macroscopically it seems to you that you put organism onto your transfer device. But the truth is that you need very little organism in order to have successful transfer, and really just touching the loop usually will be sufficient. So anyway, then you would put it on something. We're not going to do a transfer onto a plate today. That's something we'll do later. But what we said, I don't think we are. Now, we would have plates over there if we are. And then once you're done with it, once again, you fan it. Now, I would like to go over how to do the pipetting, but I think we should wait until we have all gotten started doing the aseptic transfer. So why don't we all start? First, are there any questions? I'm sure at this point everybody's completely overwhelmed, so there aren't. Why don't we all start getting our cultures? That's something I didn't say. So we get the cultures. When you are moving cultures about, make sure that, or anything that is a test tube, make sure you move it in a test tube rack rather than just holding onto it with your hand. You're going to use a single culture per pair. So you're only going to have one tube for every 2 people. Over here, we not only have racks, but we also have indelible markers. And the markers you need to use to mark the cultures, the organisms, as you just mark them onto the glass, not onto the top, but onto the glass. And that way you'll be able to distinguish the cultures from each other. There's really no other way of distinguishing them except for doing that. You also, when you grab the media is not marked either. Now, right now, it's actually very easy to distinguish the media because that's a slant, and that's a ridiculously small amount of broth, and that's broth, and that's a deep. But in other labs, there'll be lots of things that all look the same. The only way you're going to be able to distinguish them is by writing down what they are. Again, write down what they are using the marker on the glass. And with that, I'm sure I'll be speaking up at some point, but with that, I'm going to let everybody just do your thing.